Assalamualaikum. We are Group 5 from S32. We'll be presenting our task, which is the growth of human population in Argentina from 2000 to 2025. First of all, I will introduce my team members. From top left, we have Nuha, Cahya, Amira, and Dia, followed by me at the bottom, Sharizan and Nasrullah. So, I will begin with the introduction. First of all, population growth is a fundamental phenomenon that can be effectively modeled using first-order differential equations. For this project, we have chosen to analyze the population trends for Argentina from 2000 to 2025. Argentina, as one of the largest countries in South America, exhibits interesting demographic patterns that are influenced by factors such as birth rates, death rates, and migration. Understanding these patterns through mathematical modeling not only provides insights into past and present trends, but also allows us to make informed predictions about future population dynamics. So, our objective is to calculate the particular solution for human population growth in Argentina by using the Malthusian model to approximate the past and future values of the human population in Argentina, to compare the graph of the human population and the particular solution, and last but not least, to identify the factors affecting the past and future of the human population in Argentina.
First of all, we're going to let PT be the population at time in years. So we start with the differential equation, which shows that the rate of change of population is proportional to the current population. To solve it, we use the equation of variables. We now see that P and T are now at the different sides of equation. Now we will integrate both sides, and then we will solve for P. After we can express P in the term of C and KP, we get the general solution. So from this general solution, we are going to use data from year of 2030, and then we can obtain the value of A. Now we can rewrite our general solutions become like this. So next, we can also use the data from 2040 to search for value of K. Now that we have A and K value, we can write our particular solutions to become BT equal to 42388,269 exponent to the power of 0.0102 to 80.
So next, I will be explain about the graph population of Argentina between 2000 to 2025. So I will be compare between the estimated and the actual population of Argentina, which is the solid line is represent the estimated population of Argentina, and the dotted line it represent the actual population of Argentina. So the actual population of Argentina and the estimated population are quite similar from 2000 to 2023. In 2000, the actual population was 37,070,774, and the estimated population was 37,110,785, with only a small difference of around 40,000. By 2023, the actual population reached 45,773,884, while the estimated population was 46,953,213, showing a small gap of about 1.80 million. This indicates that the model was fairly accurate during these years. However, as we move towards 2034 and 2035, the estimated population starts to show slightly higher values than the actual population. For example, in 2034, the actual population was 46,057,866, while the estimated population was 47,435,915, with a difference of 1.38 million. Similarly, in 2025, the actual population is 46,337,520, and the estimated population 47,923,579, showing a difference around 1.59 million. So in summary on the conclusion we can make, the estimated population closely follow the actual population from 2000 to 2023. However, as we approach 2035, the estimation begins to show slightly higher values, which suggests that the model might be predicting population growth a bit too quickly. This could be due to the factor not captured by the model, and refining it could improve future accuracy.
Move on to the discussion part. So in this part, we are going to discuss about the particular solution that we have been calculate. So based in the books, the particular solution formula is P equals to AE in the power of KT plus C. So in this discussion part, we showed how we're going to get the K. So our T equals to 0 is in the year of 2013, while T equals to 1 is in the year of 2014. So based on step number 4, in the first question, they ask us to show the working step to find the predicted future value, which is according to the record of number of people in Argentina. We have set the T equals to 12, which is in the year 2035 as our future, and so we just substitute the T equals to 12 in the formula, and we got the 479,24730. We can see that there's a slightly higher estimated future value than the actual value based on the macrotrends.net website. So based on step 5, the second question is show the working step to find this pass value. So we have set the t equals to negative 13 in the year of 2000 as our pass value. So we just do the same, we just substitute the t equals to negative 13 into the formula of particular solution. So we got 371,09821. So we have concluded that the actual value is much more smaller than the estimated pass value.
Thus, we can conclude that the values from the particular solutions are close but not exactly accurate. Furthermore, we also calculate the percentage error for both future and past records. For the future records, we use both values from T12, which refers to year 2025, and for past records, we use T equals to negative 13, which refers to year 2020. And based on the data that we calculated, the percentage error of the future record is 3.43%, whereas past record is 0.11%. Furthermore, there is a significant difference between the actual population values and those calculated from the particular solutions. This may exist because particular solution follows an exponential model which assumes a constant growth rate over time. However, real-life factors could also influence population growth, such as changes in birth and death rates, migration trends, government policies, or unexpected events. To answer for question number 4, the population growth in the past was significantly affected by the economic crisis, particularly the hyperinflation of 1989. The crisis led to a sharp increase in financial problems, causing mortality rates rose, decline in fertility rates, and triggered a wave of emigration, as many Argentines left the country in search of better opportunities abroad. Together, these factors slowed down the country's population growth during that period. Lastly, several key factors could influence Argentina's population in the future. Firstly, economic stability that may drive immigration. Secondly, birth rates in Argentina have also been gradually declining, influenced by few factors like urbanization. Thirdly, immigration policies and regional migration trends also play a role. And lastly, public policies related to healthcare, education, and housing can also affect population growth.
For the conclusion task 1, all the objectives set forth in the study have been successfully achieved. We calculated the particular solution for human population growth in Argentina using the Malthusian model. The study provided an accurate approximation of both past and future population values. Through graphical analysis, we compared the human population trends with the theoretical model and successfully identified the key factors in influencing population changes over time. This comprehensive approach has given us a deeper understanding of the dynamics shaping Argentina's population growth. Begin to the task 2, our group has done Simpson's rule. First of all, I want to talk about the introduction for Simpson's rule. Simpson's rule is a numerical method used to approximate the definite integral of a function. It is particularly useful when an integral is difficult or impossible to compute analytically. Named after the English mathematician Thomas Simpson, this rule provides a more accurate approximation than the simpler trapezoidal rule by fitting a parabola through each pair of subintervals of the integration range. Simpson's rule works best when the function being integrated is smooth and continuous, and it is especially effective when the interval is divided into an even number of subintervals. For the objectives for task 2, number 1, to approximate area under the curve by using Simpson's rule. Number 2 is to draw the graph of a function. And also the question is given for this task. The question is, estimate the area bounded by the curve fx by using the Simpson's rule with 6 and 10 subintervals. State the final answers correct to 6 decimal places. For the 6 calculation subintervals, I just calculate it in Excel and then I just put the picture here. And first step I do is I find the delta x first by using the limits given and also the subintervals given. And I've got the delta x is 0.166667. For the next step, I just put another things such as an x, fx coefficient, and then I just list the value of the list, and then I do some calculation for coefficients times fx, and I do sum up from the all value I get from coefficient times fx and get the total value is 40.687573. And for the real calculation, for the final calculation, I just use the formula which is delta x times with the total sum up from coefficient times fx and got the final answer 0.815976. By using the Simpson's rule for 6 subintervals, we got the final answer which is 0.815976 that approximate to the real answer which is 0.814277. That's a quite near. Proceed to the next calculation which is for 10 subintervals. I just calculate delta x first and then I just use the same value and the same limits but different in subintervals refer to the question, and then I just get the delta x is 0.1. And then I just list the another things like NX, fx, coefficient, and then just do some coefficient times fx. But this one is different from before, because n here we start from 0 till 10. And then I just calculate the coefficient times fx and list all things, and then just sum up all the list, and I got the total sum up is 24.435320. And for the final calculation, for the real answer is by using the value of delta x and the coefficient times fx, the sum up from the coefficient of times from fx, and we just get the final answer is 0.815411. So for 10 subintervals, we also got an answer that approached to the real answer, which is 0.815411, which is a really approach to the real answer, 0.814277. Here is the graph. I've been using Desmos to recreate the graph, and here you can see the graph for 6 subintervals and for 10 subintervals. And you can see the area here is not different at all. We had the same area and the same shape also, but we had another different on both graphs. So let's see it. From this slide, I will show you the difference between the 6 subintervals and 10 subintervals. So we look at 6 subintervals first. We look at the graph. We see some red line, and we see a red line and a black line that does not intersect each other but nearest together, and that means the real answer is quiet approach to the calculation answer. But if you look at the 10 subintervals graph, you see that the red line and the black line is intersect or overlap to each other. And here I can conclude that that the more subintervals you use, and the more accurate the answer you get to the real answer. So based on the both picture graph for 10 subintervals show the more accurate to the real answer compared to 6 subintervals, as I mentioned before, and which means the higher number of subintervals used, the more accurate the answer to the real one. So that's our group presentation slides, and that's all. Thank you.